All right, so in this video, we are doing exponential equations. So whenever you have an exponential equation, you're going to have something that's called the base. I'll write that as b. And then you'll have something called the exponent, which is just the power that the b is being raised to. And then when you're done, you're going to have something called x, which is going to be the result. So what we're going to do is we're going to use that base and this exponent to help us solve this equation. So here I have 4 plus 5 to the x minus 3 power equals 5. And what I want to do is I want to solve this in 3 steps. I want to first isolate the variable, getting the x by itself. I want to write my solution set, and then I want to check my solution. So what I need to do is I need to get the x by itself on the left side. So I'm trying to get the x by itself. But to do that, I'm going to have to get rid of the 4, the 5, and the negative 3. I have to get rid of all those for x to be by itself. The first thing that I'm going to do is I'm going to get rid of this positive 4. I can do that by subtracting 4 from both sides. When I do that, the 4's on the left side are going to cancel out, and the 5 to the x minus 3 power is going to come down. On the right side of the equation, I have 5 minus 4, which is going to give me 1. So now I need to get rid of the 5 and the negative 3, because if I can do that, then I can get x by itself. Well, to get rid of the 5 as the base, what I'm going to have to do is take the logarithm of both sides. So that means I'm going to take the logarithm of the left side, but I'm also going to have to take the logarithm of the right side. So every logarithm is going to have a base, and we call that base b. And then we're going to have something in parentheses called the result, and the exponent is going to be on the other side of the equal sign. So for this problem, our base is 5, right? We're going to make that the base of both logarithms. So we're going to make that log base 5. So we take the logarithm of the left side. We put the 5 to the x minus 3 power on the inside. And on the right side, we have a 1. So I'm going to put that inside parentheses. So what happens with these 5s is they cancel out. They're both bases. And what's going to come down is the exponent, the x minus 3. Now, on the other side, you have logarithm base 5 of 1, which is just going to be a 0. And the reason why that's a 0 is because you're trying to figure out what exponent, if you raise 5 to, will give you 1. And that number is going to be 0. So now I have a simple equation, x minus 3 equals 0. I'm going to add 3 to both sides to get rid of that minus 3. And then I'm going to be left with x is equal to 0 plus 3, which is 3. And I'm done. I'm going to put 3 inside my solution set. So for this equation, x would have to be a 3 for it to work. Now to check it, what I can do is start off with my original equation that they gave me. So I have 4 plus 5 to the x minus 3 power is equal to 5. And we're checking x equals 3. So I want to make sure that when I plug this number in, I get a true statement at the end. So I'm going to keep everything the same, but I'm going to replace the x with a 3. But the 4 remains the same, the 5 remains the same, and the right side remains the same. The only difference is I'm just letting x be 3. So what happens on the exponent right here? 3 minus 3 is going to give me 0. we know that anything to the 0 power is going to be 1. So I get 4 plus 1 equals 5. And then if I simplify the left side, I get 5 is equal to 5. So I get that true statement at the end. And that means that x equals 3 definitely belongs in the solution set.